simplified form of this. Now I need you guys participating, like speaking up today. Let's fly through this. So when it says what's the simplified form, we're dealing with a radical, right? Square root function. Don't we break it down, pull out groups of 2 since it's a square root. Okay. So go, calculators out. Tell me some factors of 162. Now we're going to go clear down to the prime factors, meaning all of the factors. Factors mean what? Multiply to be it will be prime.
81.
2 times what?
81.
Okay, so 2 times 81. 81 breaks down into 9 times 9. 9 breaks down into 3 times 3. And 3 times 3, right? 3 for prime, 2's prime. Don't double dip. 81's not there. You rewrote 81 as 9 and 9. Don't double dip. 9 is no longer there. You rewrote it as 3 and 3. Same with that 9. Does everybody understand that? There's not a 9 and a 3 and a 3. Okay. So now because it's a square root, we pull out groups of 2. If there's 2 of them, they can leave the house. 2 3s, 2 3s. Now bang, what we're technically doing is the square root of 9, which is 3. That's why we only pull out a 3 for those 2 3s. Does everybody understand why? Okay, so we pulled out a 3. We pulled out a 3. And then left underneath was a 2. So now let's keep going. Okay, so we're pulling out groups of 2 for x to the 8. Now we can do it the long way and go write out 8 x's, right? Pull out groups of 2, but I'm going to think about it in a more advanced way. We're pulling out groups of 2. How many groups of 2 is in 8? When you do 8 divided by 2? 4. Did it come out evenly? So we'll pull out x to the 4th. Now, if you needed to go back to basics, let's say you're like, I'm kind of not sure where she got that. Write out 8 x's, 1, 2, 3, 4, 5, 6, 7, 8 of them, pull out groups of. Now, does everybody see where the 4 came from? Okay, moving on. Y to the 10th, how many groups of 2 is there? 5. Y to the 5th. Now, there was nothing left underneath for x or y, right? But there was a 2 left underneath, so we have a square root of 2. So now looking at this, whatever's on the outside, you multiply. Anything left underneath, you multiply. So we'll have 9, 3 times 3 is 9, x to the 4th, y to the 5th, and then we have a square root of 2. Now, guys, that's actually secondary math 2 level. What we learned, yes? Okay. What we're left with, in secondary 3, we were supposed to learn one additional thing. The even, odd rule. So this was all secondary 2. In this class, we learned the even, odd rule. If you have an even root and an even power, and your answer comes out to be an odd power, you have to add absolute value signs so that you don't have any negatives in your answer. Does that make sense? Because if we have plugged in a negative 1 to the 8th, would it be positive? Isn't anything to an even power going to come out positive, people?
Yeah.
So do you guys understand why we have to put absolute values on our answer to ensure that everyone knows our answer is always going to be positive? Okay, so let's look. Was it an even root? If you say no, then you don't need absolute values. So you all understand that it has to be in that order. Even, then odd. Was it an even power on x? Yes. Was it an odd power on the answer? X to the 4th. No. So we do not need absolute values because look, it's already going to take care of a negative. If we plug in a negative right here, it will only be positive. Yes? Okay, let's do this one. Even? 2 is even. Was it an even power for y? Yes. Was it an odd answer in the exponent? Yes. Therefore, if we plug in a negative right now, negative 1 to the 5th would be negative 1, right? That would be an issue. We can't have a negative under a square root. So, we're going to put an absolute value sign in here. Only around y. That's the only one that needed it. Does everybody understand? You will never have to do that for numbers. So, like, yeah, this is even, and yeah, 9 is odd, but that's a number. It's constant. Does everybody understand what I'm saying? We're good, right? Okay. Don't forget that. You will see that on your final exam. Okay, next problem. Multiplying radicals. So these are radicals. So the quiz is actually going to be focusing on rationals, the fractional stuff. This is radicals because we did do radicals the day I was gone for the sub. So it says, what is the simplified form of this? The cube root of 2x cubed y times by negative 3, the cube root of negative 4xy to the 6. I'll give you just a second to get that down. Okay, so here's the thing. There's one rule for multiplying radicals. You can always multiply a radical as long as the radical is the same. So let's look. No matter what's underneath, as long as they're the same radical. Cube root. So we can multiply them together. Does everybody understand that? So what we're going to do is multiply these together, put them all under the same root, then simplify it. Now you can do it different ways. There's many different ways. That's what I find easiest. So let's look. We have the cube root of all this stuff times -3, the cube root of all this stuff. So when we have a -3 on the outside. So I have a -3. Now I have a cube root. So I cross that out so I don't miss anything. Cube root. There was a 2 underneath. What's 2 times -4? Do you guys understand that I'm multiplying these together here? So that's -8. Then we have an x to the 3rd and x. So that's x to the 4th. And then we have a y and a y to the 6th. Y to the 7th. Now, yeah, we've multiplied these together, but when it says, what is a simplified form, you put them together, now you're going to pull out groups of 3, because it's a cube root. So 8 breaks down into 4 times 2, right? 4 breaks down into 2 times 2. So we're going to pull out groups of 3, and then it's negative. Now, can you have the negative of an odd root? Yeah, it's just the odd answer. Is this an odd root? Yes, so we're okay. Your answer will just be negative, because think about it. Isn't -2 times -2 times -2 -8? Yeah, so that's why the cube root of -8 is -2. If you don't believe me, take your calculator. Go math down to cube root, -8. It won't say error because it's not an error, it's -2. So we pull out the 2's, we pull out the negatives, so that's a -2 on the outside. Now don't forget we had a -3 already on the outside. I'm going to write that right there. Is everybody good with that? That's one of the most commonly things missed is they'll forget that there was a -3 already on the outside. Are we all good so far? Now we have x to the 4th, 1, 2, 3, 4 x's, and then y to the 7th, 1, 2, 3, 4, 5, 6, 7. We're pulling out groups of 3. So can't we pull out an x? So we are going to have an x on the outside, and then let's see, that's going to stay, right? That x is going to stay. We have a y and a y we're pulling out, which is y squared. So I'm going to just put this because I have it all on the outside. Then left underneath was a y and an x, it looks like. Anything on the outside we multiply together. So isn't that going to be positive 6? Yep. And then we have an x and a y squared on the outside. Left underneath, don't write square root, it's a cube root of x and y. Now let's check. There's our final answer. Let's check the even, odd rule. Was it an even radical? No, so we don't need absolute value sets. Questions? Okay. Next one. It says, what is the simplified form of this? The square root of 5x cubed y cubed divided by the square root of 45x to the 5th y. The easiest way to simplify a division problem is to put it together, simplify it, and then see if you need to rationalize the denominator. Because you can't have radicals in the bottom. The easiest way, I'm going to say it again, put it together, simplify it. You might not need to rationalize the denominator if you do that. You may. So let's put this together. They're both square roots, so we can say, okay, so that's the same thing as the square root of 5x cubed y cubed. Is everybody comfortable with what I'm doing? Over 45x to the 5th y. Everybody's good. So let's simplify underneath. The square root of what's 5 over 45? Let's keep things in the right places. What's 5 divided by 45? If you didn't know, take your calculator. Do 5 divided by 45. 1/9. So we have a 1 on top and 9 on bottom. Good. Then we have x cubed over x. Wouldn't that be 3 minus 1, which is 2 on top? X squared on top, people. Does everybody see why it's x squared on top?
X squared on bottom?
Oh, shoot. That's an x to the 5th, right?
Yeah.
I just saw x for some reason. So we gotta be careful to look at it right. That's my fault. X cubed over x to the 5th. No, that's not x to the 1st. X to the 3rd. So 3 minus 5 is -2, right? So that will be x squared on bottom. And then y cubed over y will be y squared on top. Now from here, now that I simplified it, we'll split it apart and simplify. So on top, we have the square root of y squared. 1 is, the square root of 1 is just 1, so I'm not going to write it. All over the square root of 9x squared. Now let's see if that's simplified. What's the square root of y squared? Y, right, people? And on bottom, what's the square root of 9? 3. What's the square root of x squared? And did we need to rationalize the denominator? No, right? There's no radical on bottom anymore, so good. Yeah. Now, in the instructions, they'll say assume all variables are positive for this, so you don't have to worry about even, odd. Otherwise, we would worry about even, odd, but it did say that in your pocket for these ones. Okay, this one. What's the simplified form of this? So negative 2 divided by 3 minus the square root of 2. So first of all, the problem is that there's a radical in the bottom of a fraction. So we've got to fix that radical. Now think about it. If you multiply, because this is what I see most commonly students do, they say, okay, so I'm going to multiply by the square root of 2. But if you're multiplying it to the bottom, do you have to do it to the whole bottom? So wouldn't that be 3 square roots of 2 minus the square root of 4, which would be 3 square roots of 2 minus 2. Did you fix anything? No, so that's why we wouldn't do that. Can anyone remember how we get rid of this? How do we get rid of a radical of something like this? Yeah. Yeah, you use the conjugate of the bottom, right? Yeah, you're right. You use the conjugate of the bottom. Don't conjugates middle terms cancel out? So the conjugate of this is a change of sign in between. Exact same terms, even if that was negative 3, our conjugate would be negative 3 plus the square root of 2, but it's positive 3. But I'm just saying, the change of sign is only in between. So our conjugate will be 3 plus the square root of 2. If you do that to the bottom, you've got to do it to the top. 3 plus the square root of 2. Then we're just multiplying by a fancy one of our choice. Is everybody good so far? So we'll multiply that in. So we're going to have to, on bottom, double distribute, and on top, we're going to have to distribute as well. Negative 2 times 3 is negative 6. Negative 2 times the square root of 2 is negative 2 square roots of 2. Right? Now, don't be scared of that on top. That's fine. You can always have a radical on top of a fraction. So now on bottom, if we multiply this out, that'll be 9 plus 3 square roots of 2 minus 3 square roots of 2, and then minus the square root of 4. Is everybody comfortable with that? So on top we have negative 6 minus 2 square roots of 2, and on bottom we have 9. And then don't the middle terms cancel out? That's what happens with conjugates, right?
Yeah.
And then we have minus the square root of 4. Isn't that minus 2?
Yeah.
So we would have negative 6 minus 2 square roots of 2 all over 7. There's our most simplified fraction, because 6, 2, and 7 don't all divide by something in common. So we'd be done. Questions on that? Okay. Couple more. It says, what is the simplified form of this? So notice we're subtracting adding and subtracting a bunch of radicals. Now remember clear back a long time ago, this lesson was many, many moons ago. I think it was the first half of the year. To add or subtract a radical, you have to have like radicals. Now, you can't just look at a radical as it is and assume it is or is not alike. Remember I talked about the wolf in sheep's clothing. I drew out a picture of a wolf in sheep's clothing, whatever, the disguise. So these are disguised. They may or may not be the same. You won't know unless it's in the most simplified form. So we're going to simplify each of the radicals and then see if we can add them or subtract them together. So looking at this piece, let's simplify that. So 16 is 4 and 4, right? 2, 2, 2, 2. So we'll pull out a 2, right? Now we can't forget that negative 3 in front. The most common error is people forget if there's something in front already. So we have 2 times negative 3, which is negative 6, cube roots of 2. Is everybody comfortable with that? For this next piece, we're going to simplify it. We're breaking down the cube root of negative 54. So give me some factors of 54. 9 times
6.
Yeah, it's 9 and 6, good. So 9 times 6, 9 breaks down into 3, 3, 6 breaks down into 3, 2. Pulling out groups of 3 because it's a cube root, and then the negative, right? We would always plot a negative when you simplify. So it'll be negative 3, so it'll be plus negative, so I'm going to write that out, plus negative 3 cube roots of 2. So looking right here, will we be able to add those together? Aren't they like radicals? Yeah. Okay, let's keep going though. Let's do this piece now. So we have negative 2, cube roots of 250. Let's do 25 and 10. 25 breaks down into 5 and 5. 5 and 2. Pulling out roots of 3. So we're pulling out a 5, and isn't there a negative 2 in front? So won't that be negative 10, 5 times 2, and then cube roots of 2. Now look, are they all like radicals? Are they all cube roots of 2? Yeah, so we can combine them. What's negative 6 minus 3? Negative 9 minus 10. So we have negative 19 cube roots of 2. The like radical part doesn't change. Yes, any questions on that? Okay. All right. This is the last one. You need it. So we didn't get to it last time. So it says, what are the horizontal and vertical asymptotes? And then graph the function. What are the horizontal and vertical asymptotes and graph the function? It's been a long time ago that we were graphing rationals. First of all, you should never really miss a graphing problem because you can always graph it in your graphing calculator, type in points. But you should be able to look and determine the shifts on this and determine the asymptotes. So first of all, the parent function of a rational function is 1 over x, right? That's non-shifted. Is everybody good with that? That's the parent function, the non-shifted function. Anything added with x is your shift for all functions. Is shift left and right, you go opposite. Anything added to the function in general is up and down, sign stays the same. So in words, isn't the shift right 2? People, right 2 up 3. Is everybody good with that? Now this is the only type of function that has 2 asymptotes. Okay, an exponential has 1 asymptote, but rationals have 2. They'll have an asymptote at the right 2 and the up 3. So I'm going to go here. Right 2, up 3, put a dot. So there is a asymptote at x equals 2, and that wasn't a very straight line. That was an awful line. And y equals 3. Okay, so when it says, what are the horizontal asymptotes? Horizon, right? Horizon. That's how I have to remember it because I get them confused too. The horizon, like, of the sun comes up like this. So these are horizontal. So you'd say horizontal is y is equal to what? 3. Vertical is up and down, like if you do a vertical jump. Vertical is at x is equal to 2. Is everybody comfortable with that? So now we would graph the function. Let's say you didn't know what the function looks like. Type it into your calculator. Let's all do that. Go y equals, type in 2 divided by x minus 2. And you'll have to be careful you type this in correctly. So I'm going to do parentheses. 2 divided by x minus 2. I'm going to close my parentheses, then plus 3. Graph. Now you should see what it looks like. Now it has little squigglies because it's not, your calculator can't stop graphing. It has to continue because it's just how the program is set up. So those squiggly lines are your asymptotes. So do you see how it looks like it's coming in up here like this? And then like this. Does everybody see it? In your calculator. Now that's a rough sketch. If we wanted to be exact, you could go second table, and it gives you a bunch of points you could plot. Okay, so it gives you a bunch of points you could plot, and then you could plot a bunch of points. But a rough sketch is probably good enough. Is everybody comfortable with that? Yes.
So what does the 2 mean above x equals 2?
The Excel, that's your A value when you multiply by 2. So your acceleration is just 2, which means it's
But it
just
doesn't
larger.
have to do the...
Shifting, no.
So wait, where did the 1x do that?
Where did the what? This is a parent function, which means non-shifted function of this. Okay, so I am being nice today. I'm feeling a little generous. You should be up through page 44. You should be. The day of the sub was here. You skipped through these pages, and then we finished up in between. We finished up the in between. So you should be up to done through page 44. I'm not assigning any additional pages. I want you to make sure you're completely finished up through page 44. The quiz isn't tomorrow. It's Thursday.